Hi, I'm Tom Berekny. This is going to be about how to manage the GNU radio ecosystem using a package manager called Nix. So first off, who am I? Major Tom Berekny. I'm with the Defense Digital Service. We are a SWAT team of nerds for the Pentagon and the Department of Defense. Mainly, we've been a rapid capability development shop and putting together small teams to go solve problems where technology has failed the Department of Defense. And we try to do something a little bit different. We're best known for things like Hack the Pentagon and some of the other efforts like that are going on. I'm a technical lead for running some of these projects for these teams. We're using GNU radio and those sorts of ecosystems quite a bit. And we ran into some various hurdles along the way. And this talk is kind of an outcropping of how we are trying to address those issues. We assume people are somewhat familiar with this, so that should be good for this audience. Why does this matter? It matters because we want to very quickly be able to develop things. I think that matters to most of the people here. And being able to have a strong ecosystem to manage builds, dependencies, testing, deployment is obviously going to speed things up. I think there's a lot of room for improvement there. So this is kind of one approach. This is a test on how we can do this. Not all figured out. There's a lot of drawbacks and including benefits in there, so I'm going to try to address those as we go. If you have any questions, feel free to ask. Stop me, interrupt me, and we'll try to address those as we go. We ran into a lot of weird problems when we had about 8, 10 people working with the GNU radio. We were working off of various branches. We're using RFNOC, so there were other compilation builds environment problems there. And this is kind of just a smattering of issues where either our dev environments were different from production build. We had, like, how do we do reliable testing? OK, we're trying to upgrade various versions because as time goes on, we're trying to use the newest and the greatest in some of the features and bug fixes that have been incorporated into the ecosystem. And then we inevitably ended up kind of wasting a lot of developer time solving a lot of problems that we don't really want to solve. This is just kind of a various list of that, but I'm sure there's more. I mean, I'm sure you guys have encountered similar situations where you're trying to just get something done, and it just seemed like you're fighting a compiler, or you're fighting the build system, or you're fighting imports, or you can't find something that should be installed, but it is, or it's your operating system that you're trying to do. And you're trying to do an actual solve a problem, trying to do some signal processing, but you can't because you're just fighting your environment. All right, so solutions to this. There are people who simply have, OK, we're going to have separate VMs for our different projects. We're going to have build scripts. We're going to put everything into like Docker containers. There's here, I'm just going to blast away on my computer and use everything on a fresh install and go by the checklist and go by the install procedures perfectly from the wiki, things like that. And I mean, that is one way of doing it. But again, you're spending a lot of time doing something that is not your primary job. All right, so a question would be, let's say, can you take something from your company or from a project or something along those lines, go back 5 years, and get that thing up and running, considering the fact that we're all working on new OSs, we're all working with new systems, new libraries and everything. Will that work? And it's this idea of reproducibility. Can you take something that's in the past, roll back, and build it? That same thing, the same concept is going to apply for something that's going to be just a few days ago, or something that was built on a colleague's computer, or with a CI system that is hosting, and there's slight differences in their environment than your environment, and you start fighting environment differences. So what do we want? We want to reliably build something, reproducibly build it. I want to be able to know that, hey, if it built for me, then it works for everyone else. I want to be able to know that, hey, if someone wants to now go back and build what I built in the future, they'll get exactly what I have rather than some variation of new libraries and breaking API changes that happen in the future. How do we isolate this? So let's say we have issues with, so common one that we ran into was we have Boost. Well, a portion of our system is running the version of Boost that is needed for GNU radio, but I have some other application that needs to run concurrently with the same one, uses a different version of Boost. So I can start isolating it with containers, but there's other issues with that, especially when you have hardware get into the mix. So how do I run 2 different applications, different versions of Boost? How do I become a good resident of the OS I'm on? Let's say it's on the same system. How do I atomically upgrade? So I want to make sure that if I want to do an upgrade, I fix everything all at once, right? Not I'm a partially upgraded system and got interrupted during updates, and all of a sudden now my system's in a broken state. How do we prevent that? And we also want to be able to experiment. So I want to throw in a new compilation flag and know that I can now run that, but if I need to, I can go back to the previous version, and it's not like I have half of my system compiled with that flag and the other one with it. So it's all these dependencies, all these things need to be tracked. All right, so how do we do this? About a decade ago, a little more than a decade ago, someone thought, hey, how about we track all these dependencies, something like the way Git does it, right? Everything is hashed, everything is addressed by that hash. It keeps things separate, it keeps things trackable in a automated way. It's hard for humans to do it, but this sort of thing is what is trivial for computers. There's a lot of SHA-256 going on. A lot of it doesn't really matter. The idea is I'm going to take that entire closure of all my dependencies, how they're compiled, what environments they were compiled in, although there are dependencies all the way down to the lowest level of what sort of a kernel it can run on, what sort of glibc and GCC versions, all their compilation flags. So every dependency is captured and gets bundled up into this hash. And that hash serves as a prefix to isolate that system and that environment from something different. So anything changes, if there's source code change, if versions got bumped, it's a brand new hash. It's not like you can't collide on it anymore. Or if you do, you'll make a lot of money. So Nix is a package manager. It doesn't replace any of your standard compilation processes. It just tries to kind of orchestrate them in a way that is understandable. There's a bunch of packages there. You can go and play with it. On our very first projects, we didn't use anything like this, and like I said, we ran into a lot of problems. On some of the more recent projects, we've been experimenting with this to see if, does this actually help us? Does it increase our ability to build things? All right, so how does this work? We'll try to do some demos here. Is that somewhat visible? All right, that's about the best we can do. So how do you use this? There is a way to use this from the command line, just the way you would use something like apt-get or brew install or things like that. It's very imperative. I want to install X, Y, and Z. I want to uninstall X, Y, and Z, and you can kind of manage it that way. That works. It's good for the system where you're trying to use it as an individual, but when it comes to trying to work in a team setting, I don't want what I did in what order I did and what I installed to cause a problem. So the way you do that is you use this idea of declarative management. So this is an example configuration. It's not all of it's needed, but I'm putting up there for explanation that, hey, I want to install this package. It's called hello. Great. So that default.nix declaration file, you run it with the nix build command, and it gives you a result. It gets placed into the store, and there's this massive prefix, looks really ugly and nasty, but that's what isolates that build from any other build of that particular package or any version of it that you have. And now that can be run. I can specify that a few ways if I don't want to do it all with these declarative style. You can see on the bottom there's another version where you just say, hey, I'm going to install that from the global Nix packages. So that's like a apt cache repository or a manifest of several, I don't know how many, tens of thousands of libraries and packages that are bundled up in this style. OK, great. So now we have hello. That's not going to help us too much, but let's see if it works. Great. So it compiled on our system, and it worked, and it ran. OK, so we worked for hello. Let's see if we can get GNU radio going. Same thing. It's going to take all those dependencies, the entire build process for GNU radio. It's going to do all the build steps, it'll do the patching, anything that's needed, and then outputs that nice structure at the end. and everything links appropriately so it bypasses your system and uses all the right libraries that are specifically for that install. So let's give that a shot. So what I did here is rather than just saying, hey, just give me what is currently the best, right? And that's good in some cases. I want the latest and the greatest. But again, in a team setting, I'm going to start pinning my versions. So here I'm very explicit. I say, hey, I want this exact version of the global environment. I confirm that it's the exact version by a SHA hash on that. That way it can't just change on me or someone can't introduce anything malicious in there without us at least detecting a change. Whether or not you actually identify it's a problem is a whole other thing. Same thing, let's build GNU radio. So that's us removing my previous one just so I don't cheat so much. And looks like it's downloading it from somewhere. Well, what happened? Well, because just like with apt, rather than building everything from scratch, I like it when I can download something that someone's already been built for me using the same exact parameters and settings. This is the underpinnings of a lot of the package managers that we have that aren't source-based. So exceptions would be like Gen 2, but like Debian and Ubuntu kind of use this model of here's their binary cache. So here it is coming along a little bit slowly because it's on my phone, but basically it's going to grab just GNU radio itself, and that should work in a few moments. Now you can imagine if you're constantly adding more and more things to your store, what ends up happening is that it fills up and you need to somehow garbage collect either old versions or things you don't use anymore. So there is a concept similar to functional programming languages where you go back and garbage collect the old things, the old generations, things you don't need. That's kind of what I did there so that I don't, I actually force myself to re-download or to rebuild this thing. If it turns out that the thing you're trying to build doesn't exist in the cache, then obviously then you just it grabs source, it creates the environment for you locally, and then you build it locally. Now, in terms of reproducibility, they do a lot of things to isolate these builds so that it's, the year is like 1970, home directories don't exist. Like a lot of things are done to make it so that when you do this, it should be reliable. It's not perfect, it's not bit for bit compatible, but I'll say it's morally compatible in the sense that I've yet to encounter a situation, unless you really try to mess with it, where you compile something in one system, you compile it on another, and they have different functionality. So they're functionally equivalent, if not bit for bit, and that's obviously an ongoing effort that we're trying to improve on. All right, so let's see if this worked. So let's see if we can get GNU radio up and running, and there it is. All right, cool. It seems to work, but we have a missing block. And that's good, because what happened is I just started GNU radio. And you can see it's looking for blocks straight up in the GNU radio directory, and obviously a little bit of my home directory. That's the default in how GNU radio works. And this block doesn't exist. OK, so how do we add that block? That's just a test case. That'll move on to the, well, actually, we'll take another step. So those builds and those downloads and how those get installed, they don't go into your standard user lib or user bin directories. They all get put into the store with that big, long, nasty hash in the beginning, and that's what isolates things and prevents things from overriding each other. It is possible then to start symlinking your way to success so that you can have all the right binaries that are installed available to you in a path if you need it. There's a whole other process along those lines that I'm not going to go into, but simply starting that program, starting the executable, will link to all the right dependencies regardless of what you're doing elsewhere in your system. So if elsewhere in your system, let's say you upgrade your kernel or downgrade boost, it won't matter because we've just bypassed your system and are using all the dependencies that are tracked in this manner. How does it do this? There's a whole configuration language. So there's a problem here in terms of learning. You have to go out and learn something a little bit different. It's not entirely alien, but it is something new to learn. So there's a cost to that. Whether it's worth it is something that you have to decide on your own. But syntax is fairly simple. It's a functional language, so you're constantly producing functions and nesting those things and trying to create a way to manage that. It does turn out to be somewhat pleasant, I'll say, to tweak things or edit things. If I have an existing package, how do I update that package without trying to recreate all the information about it? I just did this with Python 3 for the next branch, just to see how hard it would be. And it took me just a few minutes to kind of start updating dependencies, switching out the Python 2 to Python 3. And it seems like it's working. I haven't actually finished it yet, but we'll see how that works. All right, so here's kind of roughly the idea. If you have some dependencies for a login service, all those dependencies are going to be at various hashes along the way. And if we start changing things, all right, that changes the hash for anything that's dependent on it. Something else changes, that changes the hash. So it's a way to prevent that. All right, so let's go look at something from a while ago. So gnuradio, I believe it's 4 years ago, 3 years ago, I forget exactly. But there's 2 different versions that we upgraded, 3.7.9. So what I've done is went back and said, hey, I want to build 2 different versions of gnuradio based on these particular commits that are in these Git repos, and let's see what those look like. First off, let's delete what I have locally just so I don't cheat. And now we build it. So now we have gnuradio 379. So that's, when's that from, a few years ago? All right, that seems to somewhat work. Let's now go to all right, so we just bumped one version, and I have both of those living natively, not in separate containers, separate VMs, but living and running simultaneously on a single machine, and it's also from a while ago. If you dig into these, you can also take a look and see that it's not just that they were built from an old version of gnuradio, but it's also being built. It's also being built from all the old versions of the dependencies. So, all right, that's the version of Python that was being used at the time. And same with all the boost or anything else. Everything gets rolled back to what it was at that point in history so that you don't end up with like API changes or undocumented issues. And all that's living kind of simultaneously at once. All right, for some of the old builds, if it's not cached anymore, some of those versions of libraries aren't cached, you might have to start rebuilding a lot of things from way back when. Hell, I mean, if you don't have GCC cached, you're going to be building everything. It's going to take a long time to build up your system because you might have to build up core utils in your standard environment. But eventually, it'll end up working. And I cached it here just for interest of time, but it just takes a long time, but it does work if you don't have the caches ready. That's the commit, so it looks like that was in 2016. So, all right, so this was only 2 years ago. But I just straddled that bump in version numbers, kind of build both of them before and after we did that. And it seems like it worked fairly well. All right, kind of already covered some of this. This is some of the way you isolate your build from the rest of your environments to have something reproducible. Again, this is so that you don't end up with any impurities. It's not so that anything from my machine is special, some special configurations, some special settings, some special library that just seems to make it work for me and breaks for someone else. A lot of these efforts prevent that. Nice part about this is now I can take this configuration, I can take a few install instructions and give it to a colleague, and it just simply works. Now, I'm not going to say this is the best magical thing in the world, but it does seem to work somewhat reliably. It even seems to work somewhat reliably across OSs. So I normally use Linux for development, but we were able to get a colleague up and running on OS X pretty fast. What happens if the internet changes? So let's say you have a cache change, or you have someone where source code got changed where it's hosted. Well, all that with the hashing prevents that, those issues or those sorts of problems from being at least you become aware of it, because they'll tell you, hey, I downloaded something and the hash should have been X, it's different. You know, explain or go figure out or debug what happened. So you can't have this idea of someone accidentally changing something or maybe purposefully changing something that's hosted somewhere where you might have some trust. No, this is a trust but verify paradigm. All right, talked about the build cache. All those dependencies and all the source code and what they are packaged up. And I know then, hey, where it should live. So I can go ask anyone else, hey, has anyone else built it? Now, I need to trust that those are people that are trustworthy, but they have a whole trust model that goes along with that. But if I don't even want to rely on them, I'll just build it myself from source. Those are still some outgoing questions, similar to what you deal with any package manager, right? If you trust Debian or trust Ubuntu when you apt install something, you have to base your trust somewhere. You can put this in various places. So you don't just have to trust the organization that runs the build environments. We did it where we had our private builds that we were not comfortable with putting out as either open source or being done on someone else's machine, so you can point it at something internal, whether that's your company, whether that's a colleague's machine, file share, things like that. These are all possible ways of doing it, of adding your own repositories. All right, let's do it. Let's get that out of tree module fixed because we would like that. All right, so right now we have just an example module that has one Python block and one C++ block. And I'm sure most of you recognize what this is doing. It's your standard process. But this is currently being done in that isolated environment, and it's going to be all linked with the dependencies for the GNU radio version that we told it to use. I forgot which exact one I used for this one, but yeah. All right, there it is. So now I have GNU radio, and I have it with the packages. I should have put something more like with modules or something, with the module that I want. Right, so now you can start to see I can manage multiple projects simultaneously. I have a GNU radio for this project and GNU radio for that project, and they're isolated. They won't interfere with each other. The various versions of blocks won't have namespace collisions or issues like that. So this is a way to kind of isolate those things. Let's take a look. So you can go back and see, OK, this was built with GNU radio 3.7.13.3. I have my out of tree module, which is the example. And then that gets packaged up into this with packages thing. You change any one of those things, the third one will change as well. So now we have a very strict way to figure out what we're dependent on. And let's start it up. All right, so now, apologies for the weird font, but you can see we have added an additional block path. It's this example path. You can see the hints of that there, and then now our game blocks aren't yelling at us. Let's take a look at, does it actually work? Because you never know. And it's a demo. OK, great. I can gain up and down a signal. So that's how you add an out-of-tree module into this sort of thing. That's good, but there were a lot of warning errors, things that I was not happy with, and this is kind of also showcased a little bit of flexibility. There's like JTK errors and other issues, so what you can do is add stand by. Nah, OK. I must have broken this one at some point, but that'll work. So same idea. Let's build a version of GNU Radio that now has some additional dependencies brought in. Some of those JTK themes are missing, or who knows what. I'm going to just exit this maybe. Nope, there we go. All right, so now same idea. Got rid of a lot of warnings. Everything still works. It's the latest version that we want to be using, and everything's still functional. So this is yet another version of GNU Radio that is isolated from all the other ones we've seen so far. All right, so let's now let's do the whole thing. So one of our projects used RFNOC, which has this whole cross-compilation tool chain. There's a whole lot of issues with there, and then having that work simultaneously with GNU Radio. It's easy to mess something up or miss a step or install something in the wrong place, and then you have to essentially blast everything away and rebuild. We used a similar process here. So now this one's not as fancy, but same idea. You can now tell this thing, don't use your standard compilation environment, use a cross-compilation environment and this particular target. And then it builds the whole thing, and then when you go look at the result, you could see you have a bunch of ARM objects and a lot of ARM binaries that then when you transfer over will work. And they're all compiled and linked to each other, so when you look at the executable, it knows where to find it. It's got all the right hashes, it's got all the right things bundled up there. So there's some power in there. Obviously, the cross-compilation isn't magic. It's oftentimes, packages aren't ready just to be told, hey, now cross-compile to this, and everything is perfect. So that's obviously going to take some packaging work. But again, a lot of well-behaved environments, a lot of GNU Radio packages tend to be well-behaved, but I've encountered other packages where they're just simply not ready to do that sort of thing. Another approach to this is rather than trying to cross-compile something is just to build it natively. So similar idea, you can have a bunch of different builders, and these builders are, let's say, native ARM machines that you have network access to. And when you say, hey, I want this thing built for this architecture, it just says, hey, I can't build it because I'm an x86. Oh, but I have a friend over here who has an ARM machine, and it shuttles everything there, builds it locally, and then brings it all back to you as for build artifacts or for whatever you want to do with that. Then you have the beginnings of how do I use this in a pipeline. There are some CI pipelines that kind of have this already integrated into them, or you have your own, but they're usually fairly simple. You don't have to do quite a bit as long as things are packaged up. One version of this, which is native, is this thing called Hydra. Similar idea. So here's my GNU Radio demo. Looks like my latest build was 4 hours ago. You could see a few days ago I was getting ready for the demo and things were broken, but recently I have a lot of good successes. And what am I building? I have just the example that's built on x86, and then I have the ARM example that gets built on another machine. So these are now ready and packaged up and ready to be used. These things get built on every single commit, so you know that these things are running. What do I want to do next? Okay, now I've built my thing, I have my application. How do I start deploying this stuff? Again, you could, Docker is actually really amazing because it provides you that environment. But sometimes we run into issues where, okay, I run something in Docker, but let's say I have a lot of hardware connected. Not just a radio, but other pieces of hardware that's on a system I'm trying to produce. Now, having Docker manage all that, and sometimes you run into issues with that as well. There's issues with traversing their USB architecture. So that's one approach. But if you can use that because it works for your system and it helps in your deployments, and I apologize, that looks better right there. You can have Nix say, hey, well, build your application and then now put it into a Docker container. And then that Docker container you can manage with whatever management process that you have for that. So that seems to be an approach. You can also say, I want to bundle a standard deb package. So that's another way of doing it. I've seen people do Windows installers, but I've not messed with that too much. All right, so what do you do with this? You can build stuff locally. You could build stuff remotely. You could start to do the cross-compilation. These are all kind of good things. Testing. We like testing. So this is kind of one end state that we got to on one of our projects, and this was very convenient. This actually made our process a lot faster. So every time you push to some of our staging, testing master branches, each of those are going to be built. For each of those, it's not just GNU Radio, right? You have other side supporting services and applications that all have to be built, and we want to make sure all those versions coordinate. I don't want part of my application to be in like 1.0 and another version to be like 2.1. All right, so all those are managed. We even threw in at the very end there, we had some JavaScript build systems. So there's a lot of diversity in the sorts of build systems you can coordinate with this. All right, so I build my flow graph. I then spin up a QEMU VM. I run it. I got recorded data to make sure everything is working. Then I build a ARM versions of what we're trying to build on, again, those distributed builders. That all comes back to my central server. Great. I also create a fat binary, similar to how Go does it. And that's going to be a single binary that has all the things, all the various dependencies bundled into it. Again, isolating it from the rest of whatever my host system may be. So I can go take this and install this, or copy it anywhere I want, and it'll just work regardless of what sort, if it's a standard Linux with your standard, relatively recent kernel, it should just simply work regardless of what they have installed in terms of their libraries. They don't have to have GNU Radio installed. You just install this fat binary. Yeah, one drawback here is that sometimes these binaries tend to be a little bit larger. Well, that's hit or miss. So we create deb packages for all these things. Let's say we want to use local services in the system, so I can bundle all that into and use like the pre-existing Debian architecture and ecosystem for that. I then test that on a virtual machine with a fresh install of Ubuntu just to make sure that it works. I only did it with one version, but I could add several different versions to test for regression testing as we go through. Build some Docker containers, spin those up and test those, make sure I can run the same flow graph and the same processes on those. Then I throw all those things and throw them up into cache. And the last step was, okay, well, now that we've built this thing, let's actually run it. So there are then a few privileged builders that we have in a RF chamber where there's SDRs connected to them, and they actually just run RF in the loop testing. So that way, if I'm at home or somewhere and I've got a new version, I can push it, and then a few minutes later, I get a result to see whether or not it worked, and I'm in a different country. So that idea is very nice, because then if I'm developing an application, I can now know that every single commit, every single thing that makes it up to master passed, or at least from an RF perspective, did what it needs to do. So that's something that we like on the project level. I'll get into that in a second. So all this is very handy. This was trying to apply these concepts on projects, on a project-specific thing. One thing that I liked to hear earlier today was the talk about the state of GNU Radio itself. I think some of these sorts of ideas about being able to test and manage all the dependencies are extremely interesting and extremely valuable if it works smoothly. So I want to start talking with people, with anyone who has thoughts on this, on how to incorporate some of these ideas into kind of the core foundational GNU Radio ecosystem that we all love and share. To whet your appetite for anything else, now imagine you kind of take this idea of strict dependency tracking and now run your entire operating system on that, right? So all your configuration files, everything in Etsy, there's almost nothing that sits in like user bin other than what's required for like POSIX compliance. Like things like that is pretty interesting. Then you can start imagining running not just one computer like that, but multiple. So that's called Nix ops. You can spin up new images on various cloud environments that you have, or virtual machines. Same idea. You can manage services this way. There's a lot. You can go down the rabbit hole on this one. Maturity level, I don't know if it's 100% there yet for some of the later experimental things. So just kind of maybe keep an eye on that. But at least the core beginnings of it does seem to be enough for production, or at least it helped us. I don't know if it helps anyone else, but I do recommend it's interesting and worth giving a shot, especially for an ecosystem like GNU Radio, where there's often a lot of moving parts, often different languages, different things you're trying to juggle. So here's the downsides. There is a learning curve, okay? It's not super simple. Sometimes you can get lost in like nuances, but it just forces you to be disciplined, right? So if there was some weird dependency that's been creeping in that you didn't know about, or you got it for free and you got lucky that your scripts happened to get it by accident, well, this prevents you. Like if you forget about dependency, it just won't compile. It'll just yell at you because it just doesn't exist in that little isolated build environment that it produces. You can't really do a lot of like the dirty hacks that sometimes we try to do. It kind of explicitly tries to prevent you from that because those are sources of impurity. Sometimes because you're getting a lot of dependencies all the way back, you might end up with larger deployments. This might be a problem for embedded development, but generally we haven't run into a problem with this yet. So it does take more space, but then again, space is relatively cheap these days. Documentation, sometimes you just got to go play with it and read the source code. It's not the best, but again, it's still, this is something that needs to be probably better. But when you do get something that works, it is reliable, and I've started using this for not just our projects, but for other efforts as well. Coming out of this, it's interesting to look at how, going through this process, for example, we found out that GNU Radio itself has a lot of impure dependencies on where it throws configuration files, and some of those are either hard-coded or can't be easily changed, or you can't tell it to ignore them, or it tries to write things in various places, home directory. So I think coming out of this, one thing I'm going to try to do is throw some PRs up that kind of increases the purity of the GNU Radio. Yep, excellent, got some thumbs up, that's good. And then I think I would never have encountered some of those things if I didn't have the enforced discipline where something just straight up yelled at you when you broke it. So this is kind of like that drill sergeant who kind of keeps hitting you if you mess up. All right, so Nix is a package manager. It orchestrates your build process. What do? We built a few versions of GNU Radio, a few that are pretty old. We threw an out-of-tree module for that as well. We tested those flow graphs. Then we figured out, well, hey, how do we share this, right? If I just share that Nix expression, which is a declarative thing, kind of like if you think like a Terraform script or maybe a Docker file is almost the same idea. You could use things like Docker. You can integrate this with other environments that you're familiar with, and it could just be an extra tool in your toolbox. So I do recommend it. Give it a shot. This presentation was stolen from someone else that did kind of like an intro. I tried to make it applicable to GNU Radio and share about some of our experiences on how we use this in a team. Yes, before Ben has a chance to yell at me, all this stuff I'm trying to, this is all out in the open, it's all open source. Nothing's behind a closed curtain. So I'm going to try to see if we can use this to support this community. Questions?
I think we have time for one question, if the next presenter can get lavaliered.
While you were speaking, I tried to find an RPM of Nix for CentOS, and I couldn't do it. We'll talk on the side on how I can install it.
Yep.
All right, thank you.
Of course. That was a quick question. One more?
It sounds like this could be useful for very specific environments for offensive security research or other cybersecurity activities. Any comments on that?
The strict tracking of everything, I think, will definitely help that. I've not played in that space very much, so I don't know if I can comment a great deal. But yes, in that sense, it's helpful because you can isolate yourself from your local environment. And because you can have very strict dependencies, it's much easier to either reduce the size of whatever it is that you're doing, or to make sure that what you end up with does work the way you expect. So I think there are some benefits. I'm just probably not the right person to explore them.